All right, let's look at this problem called minimize the sum. So what is given to us in this problem is essentially we are given an array and it says that from this array take any two elements, whichever two you want, add their sum, and whatever the sum is, put that sum back into the array. And keep doing that till the number of elements is just become one. So just have a read. So you're given n elements, you can remove any two elements from the list, note their sum, and add the sum back to the list. Repeat these steps while there is more than a single element in the list, and at the end, our task is to minimize the sum chosen. So essentially, to minimize the sum, that means at any point, I want to find out the two smallest numbers, right? So look at this example. So it says 1, 4, 7, 10. It takes 1 and 4. Why it takes 1 and 4 is because those are the two smallest ones. So 5 it notes and 5 what it puts back. Now this array has 5, 7, and 10. Which are the two smaller ones? 5 and 7 are the two smallest ones. So it takes 5 and 7, adds there some 12, puts it back, and 12 is also added to the sum that it was noting, right? So when we see this, we figure out that okay, we essentially want to keep track of minimum always, like not just in the beginning, but also when we are adding a new element back, right? So we want we want a data structure that can give me the minimum at any point in time. What is the data structure? We can use a min priority queue, right? Once we figure that out, it's just basic code. So let's say we do priority queue of integer. It's called priority queue equals to new priority queue. So then what are we saying? Well, to begin with, let's just add all the elements into the priority queue. So int I equals to 0, or rather for each num in array, just do priority queue dot add array, sorry, num. And then what? Then we go through the priority queue till its size is greater than 1, right? So while priority queue dot size is greater than 1, what we're gonna do? We're gonna get the first smallest element. So we remove the smallest element. We get another smaller element after that. So then what do? Whatever the sum we get, we add it back into the priority queue. So priority queue dot add, we go a plus b. And also we are maintaining a total. We keep tracking of the sums that we are getting, right? So let's initialize the sum to 0, and then we can do sum plus equals to the sum of these two guys, right? And we'll always be taking the minimum, and so here, not here, uh, we return the sum. So that's the code. Let's compile and run. Evaluating 3939 is correct, so let's submit and see whether all test cases pass or not. And meanwhile, let's talk about the time complexity. So we can clearly see we are doing the basically adding or removing elements into the priority queue is log of n, and so we are doing a constant number of log n operations per element, right? So the overall time complexity would be n log n. All right.